Hello students and welcome to Math Weekly number 17. In this video our focus skill will be on properties of parallel lines. Let's begin with a definition for parallel lines. Parallel lines are two lines that never cross because they have the same slope. Now to understand this definition you have to have a good working knowledge of the word slope. Slope is a constant rate of change. It is expressed as a ratio. To calculate that ratio, we need to calculate slope on a coordinate plane by writing a ratio of the change in y over the change in x. A lot of people refer to this as the rise over the run because rise goes up and down just like the y-axis and run goes left to right just like the x-axis. So let's begin with some basic examples on how to calculate slope on a coordinate plane. Now remember, slope is rise over run. Rise can be positive or negative, and so can run. So we have to determine if we're going up, it'll be a positive rise. If we're going down, it's a negative rise. If we go to the right, it's a positive run. And if we go to the left, it's a negative run. Personally, I like to start with the leftmost point, which is A, and I'm just going to move upward, not diagonally, just upward until I'm in line with B. So there's up 1, up 2, up 3, up 4. So I've gone up, which is positive, 4 for my rise. So my rise is positive 4. Now I need to determine how much I'll run. Well, I know I'm going to be moving to my right, so that's a positive run movement. 1, 2, 3 blocks. So I went positive 3 to the right. So my ratio is positive 4 to positive 3. Now, a positive divided positive makes a positive, and 4 over 3 cannot be reduced, so my slope is 4/3. This is an example of a positive slope that results in a fraction. Now let's look at an example of a negative slope. Remember, slope is rise over run. Again, I like to start at the leftmost point, which in this case is A, and I'm not going to be able to go up to get to B. I'm going to have to go down. 1, 2, 3, 4, 5, 6 blocks. So I went down, so that's negative 6. Now I'm going to be moving to the right. 1, 2, 3. And since I went to the right, that's positive 3. Now, a negative divided positive results in a negative, and 6 will divide by 3, so 6 divided by 3 is 2. So our slope is negative 2. This is an example where the slope is negative because the line's going downward and results in an integer as the slope. Now let's apply calculating slope to proving that two lines are parallel. So in this example, we're going to prove that these two lines are parallel. Now in the previous examples, I gave you points that were labeled A and B. We'll just have to make up our own points on the line. You cannot choose a point randomly on the graph. It has to lie on the line. So what I look for is look down the axis and across the axis lines for a perfect point, one that's made of whole numbers. So I just go along the graph till I find one. Okay, here's one. I'm going to call that A. I'm just going to keep going until I find another one. Okay, here's one. I can call that B. And I could have picked, here's another one. I could have picked that one if I wanted to. It doesn't matter. So I'm going to call the first line, line AB. And since I'm calculating the slope of it, I'm going to write slope in front of it. So slope of line AB equals, now do rise over run, up 2, so that's positive 2, and run 3. Positive 3. So our rise is positive 2 and our run is positive 3. A positive divided positive is a positive, and 2/3 is a fraction that doesn't reduce, so we just leave it like that. Now we're going to do the same thing for slope of the other line. We'll call this line CD. So let's find 2 points. Okay, here's one, we'll call this C, and here's one, we'll call it D. So let's see how much we need to rise to get from C to D. So I'd have to go 1, 2, 3, 4, see here, I'm now here in line with D, so up 4, and over 1, 2, 3, 4, 5, 6, up, or run 6. So our slope is positive 4 over positive 6. Now, positive divided positive is a positive, and 4 over 6 is a fraction, but we can reduce that fraction by 2 to get 2/3. Now, you'll see that I purposely did not pick this point here as an example of you can reduce it to make sure they're equal. So then we would conclude, and this is how we prove it, line AB, we'll put lines AB and CD are parallel because they both have a slope of 2/3. Let's now look at another example. In this example, we are going to prove that a shape is a parallelogram. Now, to prove that it's a parallelogram, you have to understand the definition of a parallelogram. A parallelogram is a quadrilateral with two sets of parallel lines. Okay? Now, if it said trapezoid, it would only be one set that you'd have to prove, but we have to prove two in this example. So you can tell by looking at it that line AB and line CD are parallel. Now we just need to figure out why. We can also see that line AD, do you see it there on the side right here? And line CB are parallel. And now we just need to prove it using their slopes. So let's start with line AB. Let's do rise. So we rise how many? 1. And we run 1, 2, 3, 4, 5, 6, 7, 8. So our slope is 1, positive 1 over positive 8, or 1/8. Now look at D. We go up 1 and over 1, 2, 3, 4, 5, 6, 7, 8. So its slope is also 1/8. So we can finish our statement now. Line AB and line CD are parallel because both have a slope of 1/8. Now we go on to AD and CB. So I'm going to go ahead and erase this just so that we have less visual clutter to look at. So let's start at point D. We need to go down 1, 2, 3, 4, 5, 6, 7. So I went down 7, negative 7. And I'm going over 1, 2, 3, 4, positive 4. So I went down 7 and positive 4 over. So negative divided positive is a negative, and 7/4 will not divide or reduce, so I just leave it like that. Now I need to do the same thing for CB. I go down 1, 2, 3, 4, 5, 6, 7, so that's negative 7, and over 1, 2, 3, 4, positive 4. So our slope is negative 7 over positive 4, or negative 7/4. So I would go on to say line AD and line CB are parallel because both have a slope of negative 7/4. Now lastly, I'll type my conclusion. I'm going to go ahead and type it this time. So therefore, quadrilateral ABCD is a parallelogram because it has two sets of parallel sides. And that proves now, not just says that it looks like it proves it mathematically that it is indeed a parallelogram. So what have we learned about parallel lines in this Math Weekly? First, parallel lines never cross because they have the same slopes. To prove that lines are parallel, show that their slopes are equal. To calculate slope on a coordinate plane, use rise over run. A trapezoid must have one set of parallel lines, and a parallelogram must have two.